Lesson 3, Part 2. So we've done Part 1. We filled out page 1 of our notes. Now we're going to look at some examples of chemical change, of chemical reactions. So let's do this first one together. Bread dough baking. What is some of the evidence we would see that a chemical change has occurred, a chemical reaction has occurred? So let's look at all of our 6 different ways. Color change, odor change, temperature change, gas, light, solid. All right, so here, when bread bakes, we definitely see a color change, right? We see the browning of the bread. Okay, and so what you're going to do, answering in the on the questions that pop up in the video, you're going to identify what changes, what signs of chemical change you would see in each of these. Are all different chemical changes, chemical reactions, and you're going to identify what could you see, what would be those evidence. Okay, so coming back, let's write those down, what we saw. So eggs rotting, you'd certainly see an odor, right? You might also see a color change, right? They might be a different color when they're rotted. So odor and color changes. When wood turns to ash when it's burning, you definitely are seeing a color change. Certainly wood burning, heat is produced, so you'd also see you'd have a temperature change, so color and temperature change. When you add baking soda to vinegar, you see lots of bubbles. Those are actually carbon dioxide bubbles. They're a new substance, so that is gas production. And then fireworks, definitely a color change, right? We see color. Light is produced, right? Light production, so color change. Light is produced, and definitely also a temperature change as well. They get hot, so temperature change. Okay. Now in the questions that pop up in the video, you're going to look at this list and identify which of these are chemical changes and which are physical changes. Okay. Okay, now and then on your notes, write down C or P. So for example, bananas rotting, that is a chemical change, so we'd put a C. Crumpling a sheet of paper, we haven't changed, it's still paper, that would be a P. Okay, and then you write the rest here. All right. The law of conservation of mass. So this is a law in science, and it states that matter is neither created nor destroyed in a chemical reaction. It is conserved, meaning the amount of matter does not change. Conservation, things don't change, right? It is conserved. So because you can't just get matter out of nowhere, you can't just have atoms appear or atoms disappear, then that means that the mass of the reactants, how much the reactants weigh, if we could put them on a scale, is equal to the mass of the product. So nothing appears or disappears in a chemical reaction. So in your video question, you're going to see if you can identify what this chemical reaction is called. It's something you've heard of before. You'll have some choices to choose from. The inputs are carbon dioxide and water, and sunlight makes the reaction go, and chlorophyll is the pigment in, I'm not going to give away where that chlorophyll is, it's in an organism that facilitates this process. And then the reactants, the thing that come on the other side, are glucose and oxygen. Okay, answer that question. All right, coming back. If you said photosynthesis, you were right. Photosynthesis. Photo meaning light, synthesis meaning putting things together, building, synthesizing, building. So it's taking a smaller molecule, enlarge this a little here, carbon dioxide, and we can see here's 6 carbon dioxide molecules, right? 1, 2, 3, 4, 5, 6. That's this number here, 6. and 6 waters. And those are smaller molecules, and then they're being, with the power of sunlight, the photo power, they're synthesized into this big, awesome molecule called glucose, which is the sugar that plants produce. And all of us animals eat plants to get that glucose. And then oxygen is given off as a waste product. And the oxygen, the tree, like say a tree is doing photosynthesis, right? It will make sugar for itself, right? It makes its own food to use when it's nighttime and it needs energy. And it releases oxygen as a waste product. Of course, we don't think it's a waste product. We need to breathe oxygen, so it's very convenient for us. So here's what you're going to do. The question on your video. You're going to identify how many of each type of atom. We see there's oxygen atoms, carbon atoms, and hydrogen. So oxygen is O, carbon C, hydrogen is H. And you're going to count how many there are in the reactants altogether, and then in the products. We'll do one together first, and then you're going to answer some questions in your video. So how many oxygen atoms are there? Well, we can count. There's 6 CO2 molecules, and they each have 2 atoms. So this will be 2, 4, 6, 8, 10, 12. And then in the water, we have 13, 14, 15, 16, 17, 18. 18 oxygen atoms. And then in the products, we have 1, 2, 3, 4, 5, 6 oxygens, 6. And then here we have 2 each. We have 2, 4, 6, 8, 10, 12. 6 plus 12, also 18. Aha! Reactants and products, same number of oxygen atoms. Okay, you count those and answer the question in your video for carbon and hydrogen. All right, coming back, let's see how you did. So you should have gotten 6 carbon atoms in the reactants, and then 6 appear in the products. You should have gotten 12 hydrogens, and then we also see up here 12 hydrogens, and the 12 in here in the products. So notice this is a really good demonstration of the law of conservation of mass. The mass of the reactants, so for each element, each type of atom, same number of atoms in the reactants as the product, right? We had no oxygen atoms appear or disappear. Carbon atoms stayed the same and hydrogen atoms stayed the same. They just got rearranged. Original bonds were broken in the carbon dioxide and water, and then new bonds were formed to make glucose and oxygen. Okay, that's it.